connection that's going to help us a great deal towards graphing trigonometric functions is to look at something called the wrapping function. Now with the wrapping function, you have a real number t that's along a number line. So consider this like a number line where I have 0 on my number line and I have my positive numbers going to the right and the negative numbers going to the left. Now if I take this number line and I put 0 at the positive x-axis, and those that were the positive numbers going to the right, I'm going to go up and around, and those that were the negative numbers to the left, I'm going to go down and around, then this number line can also measure out the length of the arc as I follow along the circle. Now here, I'm actually looking at the unit circle. So I have drawn this where I've really zoomed in on a circle and I've made the radius 1. So from here, the origin, to the point on the circle on the positive x-axis is 1 unit. So what I did with these little squares is just to show you that if you had this on graph paper and then you zoomed in, this would be unit by unit. This would be 1 grid of your graph paper. This would be another grid of your graph paper, etc. So the unit circle means that the radius is 1 unit. So I have from the origin over is 1 unit, and that also coincides to the ordered pair point on the x-axis where I went right 1, but I didn't go up or down. So that point is the point 1, 0. Just like when we're dealing with ordered pairs x, y in our algebra classes. Now with the unit circle, and I have like our origin and our wrapping function, when I look at the arc length of the circle, the arc length of the circle in radians is going to be the same as the radian measure of the central angle. So if I measured this out and it goes from 0, from the 1, 0 ordered pair up to this point on the positive x-axis, that means that this wrapping function, real number length, is pi over 2. So the angle is pi over 2. Now the wrapping function itself is defined to be, well, they just use the first letter of the word wrapping, w. So w of t, t is the real number of the arc length that's around the outside edge of the unit circle. So t would be like the pi over 2 that I did, or if you did like a pi over 6 for your real number arc length, is equal to the point x, y, where t is a real number and the point x, y is a point on the unit circle. So if my real number t is just 0, then my wrapping function of 0, 0 is the t, the length on your real number, is equal to the ordered pair point, the x coordinate, comma the y coordinate. So that would be 1, 0. And then if I looked at all of our other nice angles in radian measure and just kind of set up what these ordered pair points would be, well, if I have an arc length of pi over 6, the central angle of pi over 6 was the same as the degree measure of 30 degrees. So remember that the cosine of 30 degrees is the square root of 3 over 2, and the sine of 30 degrees is a half. Also remember that when we did the trig ratios, our cosine of our angle was x over r, and our sine of our angle was y over r. Well, if it's the unit circle, r is 1. So the cosine of an angle when we're dealing with the unit circle is going to be the same as the x coordinate of the point on the unit circle. And the sine of the angle is going to be the same as the y coordinate of the point on the unit circle. So I'm going to go ahead and take this part of the grid off now that we've determined it's the unit circle, and that'll give us space to put our ordered pairs. So when I do the ordered pair for the arc length of pi over 6, the cosine of pi over 6 is the square root of 3 over 2, and the sine of pi over 6 is a half. And I'll go ahead and mark that that is with our angle of our pi over 6 by doing the wrapping function of pi over 6. Now the next one is pi over 4. And remember, the cosine of pi over 4 is the square root of 2 over 2, and the sine of pi over 4 is the square root of 2 over 2. So that's your wrapping function of pi over 4. The next is pi over 3, and the cosine of pi over 3 is a half, and the sine of pi over 3 is the square root of 3 over 2. And that's your wrapping function of pi over 3. Now, when we want to use these to go and help us figure out the trig functions of the real numbers throughout the entire number line, so we're actually going to look at where we have our 0 and then our number line, positive going right, negative going left, and then having our values along the trig functions of real numbers along that. We'll want to remember some of these ratios of the nice angles. And so since I can go forever right and forever left, that is going positive direction for forever right and then going negative direction for working our way towards the left. So we'll want to try to get comfortable with finding these values on the unit circle. Let's see the rest of them and how symmetry can play in. Well, the point for the wrapping function for pi over 2, well, this is the ordered pair point on the positive y-axis. So just think, like sometimes we can get so mixed up with the new concepts that we forget that there's common sense that goes along with this. So think, if you're at the origin and you're not going right or left, but you're only going up 1 unit, the ordered pair for that would be 0 for the x-coordinate, positive 1 for the y-coordinate. So this point right here is don't go left to right, so 0, 1. And then also remember, within each ordered pair on the unit circle, our x-coordinate is the cosine of the angle, and our y-coordinate is the sine of the angle. And I'm using t's here instead of theta, just to remind myself that these are of real numbers. So they have to be the ones that are in radian measurement. Radian measurements are real numbers. So looking at that then as well, and I'll bring that down a little bit further to make sure it's in the screen. So cosine of the angle is the x-coordinate, sine of the angle is the y-coordinate on the unit circle. Just as a memory device, just think x is listed first when we do the x comma y, and x is earlier in the alphabet, x comma y. And for the first letter of the words of the trig function, c becomes before S in the alphabet, so C goes first in the ordered pair and S for sine goes second in the ordered pair. Just a memory device, not a reason why it happened, but it helps you tag which one's which in the ordered pairs. Now, if you can just get this first quadrant down, you've got the whole circle because you've got symmetry on your side. And the 45 degree, the pi over 4, that's when the sides of the right triangle were the same as each other. And that's where you got square root of 2 over 2, comma, square root of 2 over 2 for the cosine of the pi over 4 and sine of the pi over 4. So the over 4s are always going to be square root of 2 over 2, square root of 2 over 2 for the cosine of the angle and the sine of the angle. You just have to figure out what plus or minusness it has. And you find out what plus or minus it has by the movement you take off the origin. So if I'm going to this pi over 4 spot, which is 1/4, 2/4, 3/4. Then to get into the second quadrant, I have to go left, so my x-coordinate's got to be negative, and up, so my y-coordinate has to be positive. So that's going to be for my wrapping function for the pi over 4. It's going to be left, so negative square root of 2 over 2, comma, positive square root of 2 over 2. And symmetry then gives us that the pi over 6 that lands into the second quadrant, I have to go left and up. So this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So the wrapping function of 5 pi over 6, or those that have my reference angle of a pi over 6, it's going to have the correct plus or minusness, but the rest of it's going to be the cosine of the reference angle of pi over 6 is square root of 3 over 2, and the sine of the reference angle of pi over 6 is going to be a half. But left and up, that gives me negative square root of 3 over 2, comma, positive a half. And for the pi over 3 reference angle, that's going to be the same as my pi over 3, just with the correct plus or minusness. So this dot is going to be left and up, so it's negative a half, comma, positive square root of 3 over 2. Now another thing I want to mention, we'll go and fill out the rest of these as well and then answer the questions, but another thing I want to mention is also, again, try tagging some common sense. So for the pi over 6 and the pi over 3 with the cosine of the angle and the sine of the angle, you're like, oh, it's got to be that square root of 3 over 2 or a half. I know those two ratios go together when I'm looking at the ordered pair. But which one's which? Well, look at the decimal of it. If you take the square root of 3, which is about 1.732, and you divide it by 2, you're going to get about 0.8660. All right? Now, if you take 1 and divide by 2, you get 0.5. 0.8660 is bigger than 0.5. So the square root of 3 over 2 is bigger than a half. Now, think about getting to this point. I, from the origin, have to go more over than up. It's a longer distance over than it is up to get to the pi over 6 real number measurement of that angle. And so that x-coordinate is going to have to be the bigger of the numbers. And since the square root of 3 over 2 is the bigger of the numbers, that ordered pair is going to be the square root of 3 over 2, comma, a half. To get to the over 3, pi over 3 dot, I have to go over a little bit, but up a lot. So there, my x-coordinate's got to be the smaller of the two. My x-coordinate's going to be 1/2, and my y-coordinate's going to be the square root of 3 over 2 for all of the reference angles that have over 3's. So that can really help you figure out, like when you take your reference angle and then you take your information from the first quadrant, it can get you the rest of the way through. How about for pi? Well, my wrapping function for pi, well, just think, from the origin, I'm going to go left 1 and none up or down. So that's negative 1, comma, 0. This one is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. So that's 7 pi over 6. So the wrapping function for 7 pi over 6 has a reference angle of pi over 6. So it's going to have the same ordered pairs. But to get to the third quadrant, I have to go left and down. So that's going to be a negative square root of 3 over 2, comma, negative a half. And for my 1/4, 2/4, 3/4, 4/4, 5/4, for my wrapping function for 5 pi over 4, the over 4's are the square root of 2 over 2, comma, square root of 2 over 2 for the cosine of the angle and the sine of the angle. But again, left and down. So that's going to be a negative square root of 2 over 2, comma, negative square root of 2 over 2. And then here, this is the wrapping function for 4 pi over 3. And that's going to be negative a half comma negative square root of 3 over 2. I have over a little, left a little bit, down a lot. So that's why it's going to be that ordered pair. And then for the rest of the dots, this one is don't go left or right, go down 1. So 0 comma negative 1. Here I go right and down. So the x coordinate's positive and the y coordinate is negative. Right and down, x coordinate is positive, y coordinate is negative. And then right and down, x coordinate is positive and the y coordinate is negative. So with each of these, let's go ahead and look at what we have in terms of answering the questions that are asked here. So first, this just says find the coordinates of the point P on the unit circle. So we just want the ordered pairs from the unit circles. So for 5 pi over 3, so 5 pi over 3, that's 1/3, 2/3, 3/3, 4/3, 5/3. So for 5 pi over 3, I have the ordered pair 1/2 comma negative the square root of 3 over 2. For 2 pi over 3, now this is still a pi over 3, so it's still going to have then that 1/2 as the x coordinate and square root of 3 over 2 for the y coordinate. But where does 2 pi over 3 land? It is in the second quadrant, so I have to go left and up. So that's going to be negative 1/2 comma positive the square root of 3 over 2. How about for pi over 2? Well, pi over 2 has the ordered pair 0 comma 1. Then for negative 5 pi over 6, so go down and around. So go down 1/6, 2/6, 3/6, 4/6, 5/6. So negative 5 pi over 6 has a reference angle of pi over 6, but it's in the third quadrant. So both coordinates are going to be negative. So it's going to be negative square root of 3 over 2 comma negative a half. So negative 3 pi over 2, go down 1/2, 2/2, and then 3/2 takes me to this dot, which is 0 comma 1. 5 pi over 4 has a reference angle of pi over 4, so I know it's going to be the square root of 2 over 2 comma square root of 2 over 2. I just have to find the correct sign, and it is 1/4, 2/4, 3/4, 4/4, 5/4, and we have it actually right here, 5 pi over 4. My ordered pair is going to be negative square root of 2 over 2 comma negative square root of 2 over 2. Now that's for the ordered pairs on the unit circle. The next one just says find the wrapping function for these real numbers. And remember, the wrapping function is defined to be the point on the unit circle for that particular real number. So the wrapping function for pi over 4 is actually asking you the exact same question that it asks you up here when it says to find the ordered pair, the coordinates of the point on the unit circle for a particular angle. So this wrapping function of pi over 4 is just the ordered pair square root of 2 over 2 square root of 2 over 2. And the wrapping function for negative 5 pi over 6 is going to be my negative square root of 3 over 2 comma negative a half. So hopefully that'll give you some information that'll be handy in really getting a hold of those trig functions, of the special angles, and of the wrapping function. Before we leave this segment, I want to just bring to your attention a couple things. First of all, when I'm looking at going in an angle that's a positive direction and then going the same amount only a negative direction, and I think about what's going to happen in terms of the trig ratios of those angles, well, if you notice, if you go up and around and then down and around the same amount, you have the symmetry working on your side, right? And so these dots are going to have the same x coordinates, but their y coordinates are going to be opposite in sign, because your x coordinate is your overness and your y coordinate is your up and downness. And so I went over the same amount, but one went up above the x-axis and the other one went down below the x-axis. And that works throughout the entire circle as you go. So one thing that we have that we see on this, and I'm going to write it right up here so we have our information on that, the cosine of a negative real number, and it works when you have degree measurements as well, but the cosine of a negative real number is the same as the cosine of that real number. So the cosine of negative pi over 4 is square root of 2 over 2, and the cosine of positive pi over 4 is square root of 2 over 2. They'll have the same ratios, but the sine of a negative real number is the opposite of the sine of the real number. So the sine of negative pi over 4 is going to be negative the square root of 2 over 2, and the sine of positive pi over 4 is going to be positive the square root of 2 over 2. They're opposite in signs. This is going to come into play quite handy when we go and talk about even and odd functions with trig functions.